Hey guys, what's going on? Today we're going to be talking about just some really basic electrical components here. These are all really small size and just kind of give you a little view of what they actually look like in the real world. As if you're just taking theory classes or something, you don't actually get to see anything in real life. So first we'll start with these little guys are resistors. And if you notice, they each have different color bars going down them. And that determines the resistance value. And that is called the color code. And I will make a video on how to do color code and how to calculate those numbers. It's not that hard, but this is what a resistor looks like. This is where the current is actually going to be resisted in this little guy, and the simplest way to think of a resistor is any sort of oh, perfect. Look at this. We got a heat lamp here. So this is where you would use resistors to literally create heat, or if you have a space heater. I got one somewhere around here, but yeah, so it's basically just to literally to cause heat. I mean, there's obviously other purposes to reduce to make voltage drops and things like that. There's tons of uses for them. So, but the simplest way to think of them is they resist the electrical current, and so they create heat. Moving on here, these are called capacitors. And really what you need to notice is one leg is longer than the other. And that's going to give you your either negative or positive side. So you can see one side is longer than the other. You have 100 microfarads and 25 volts, so it'll give you the values there. Again, this is a teeny tiny one. They come in all different sizes. And so also what I wanted to show, this is a small one, but even so, my dog's been crazy. Even so, these are capacitors as well, even smaller, as well as these guys. And you'll also see them, capacitors, start motors, and stuff like that. Basically, they can release an electric charge much faster than any standard motor. They will charge until they are equal with whatever size battery you're using. So say you hooked it up to 9-volt battery, it's going to charge to 9 volts. The key difference, well, the bad side is it will not hold our charge as long. It's just not. It's not meant to be used as a battery. It's meant to be used with a battery, because what's going to happen is it's going to charge to the same voltage as the battery itself. But the difference here is it's going to release the current at a much faster rate. So instead of, say, arbitrarily 10 electrons a second, this will do like 1,000 electrons a second, which is going to increase torque. It's going to increase power. It's going to help a motor get running, get started, get turning. It's going to help, think of like a winch or a wench. Damn it, what are those called? Like a pulley system, basically, that you've got, your pulley here, and then you've got your rope, and say it's traveling like that. This speed of movement is going to increase drastically when you hook up a capacitor, hence why you'll see them attached to starter motors and such. So another thing, that's all I have to say. We have some LED lights. You might remember light brights, depending how old you are when you were a kid. But these are mostly, or at least what I've seen them used for in circuits, is it'll be connected to, say, like a sub pump motor, and it'll turn on if like the pump isn't working, or it's or something's supposed to be happening and it isn't happening. They say there's a short or a break somewhere. Then the current will travel through this light instead, showing that something is not operating the way it's supposed to be. There are obviously other uses, but that's the main way way that I've seen them used. And lastly, these aren't necessarily typical of what they look like, but this is a rectifier. You can create these out of diodes. You need 4 diodes, and you can create a full bridge rectifier. And what that means is you're essentially changing your AC waveform into a DC waveform. So what that means is if you have your AC waveform, which I'm looking through the phone while I do that, so it's weird. But so you have your AC waveform, your positive and negative states. So let's mark it like that. What happens is you get your rectifier, comes out on the other side, and it's just DC. Let's see if you can see that better. Yeah, so basically you're turning your AC into your DC, so you can say plug in your phone, if you want to power a fan, basically anything, not anything, but a lot of things you charge, like your laptop, your phone, that box that comes off the cord is probably a rectifier or an inverter. Most likely a rectifier, which is going to just be able to have that device run on the AC waveform when it's designed to run on a DC waveform. Yeah, that's really all there is to say about that. And yeah, that's it. So have a good one, folks, and hope that helped.